Chapter 17: Temperature and Heat. Problem 1. You put a bottle of soft drinks in a refrigerator and leave it until its temperature has dropped to 10 Kelvin. What is the temperature change in Fahrenheit and in Celsius? The temperature of the bottle dropped from change in temperature of Kelvin equals negative 10 Kelvin. Change in temperature of the bottle can be calculated using the equations 1 and 2. Equation 2 can be written as Fahrenheit is equal to 9/5 times Celsius plus 32, and Celsius is equal to 5/9 Fahrenheit minus 32. Substitute Celsius in the equation. Kelvin is equal to 5/9 Fahrenheit minus 32 plus 273.15. Hence, the temperature difference in Kelvin scale is temperature for Kelvin 1 is equal to 5/9 Fahrenheit minus 32 plus 273.15. Temperature for Kelvin 2 is equal to 5/9 Fahrenheit 2 minus 32 plus 273.15. Subtract the equation 3 from equation 4. So, temperature of Kelvin 2 minus temperature of Kelvin 1 is equal to 5/9 temperature of Fahrenheit 2 minus temperature of Fahrenheit 1. So, is equal to 9/5 times negative 100, which is negative 18 Fahrenheit. Change in temperature of the drink in Celsius is the same as change in temperature in Kelvin. So, Celsius is equal to negative 10 Celsius. Problem 2. Steel train rails are laid in 12 meters long segment placed end to end. The rails are laid on a winter day when their temperature is negative 9 Celsius. How much space must be left between adjacent rails if there are just to touch on a summer day when their temperature is 33 degrees Celsius? If the rails are originally laid in contact, what is the stress in them on a summer day when their temperature is 32 degrees Celsius? Given length is equal to 12 meters, temperature 1 is equal to negative 9 Celsius, temperature 2 is equal to 33 degrees Celsius, and the constant of steel is equal to 1.2 times 10 raised to the negative 5th Celsius. To calculate how much space must be left for the steel to expand, we should calculate L, which represents the space before expand and employed by L is equal to initial length times constant of the steel times temperature. So 12 times 1.2 times 10 raised to negative 5th times 33 minus negative 9, which is equal to 6.048 times 10 raised to negative 3 meters. B. We can calculate the stress of the steel by stress is equal to negative Young's modulus times constant times change in temperature, where Y is Young's modulus and it is a unit of pressure, and for steel, Y is equal to 2 times 10 raised to 11 Pascal. Stress is equal to negative 2 times 10 raised to 11 times 1.2 times 10 raised to negative 5 times 42 degrees Celsius, which is 100.8 times 10 raised to 6 Pascal. In conclusion, negative sign is due to the stress force is comprehended. Problem 3. A US penny has a diameter of 1.9 cm at 20 degrees Celsius. The coin is made out of metal alloy Mostly zinc, for which the coefficient of the linear expansion is 2.6 times 10 raised to negative 5 Kelvin. What would be the diameter on a hot day in Death Valley, which is 48 degrees Celsius, and on a cold night in the mountains of Greenland, which is negative 53 degrees Celsius? The given is the diameter initial is 1.9 cm, temperature 1 is 20 degrees Celsius, and the constant of zinc, which is 2.6 times 10 raised to negative 5. Calculate the new diameter in the Death Valley on a hot day at temperature 2 is equal to 48 Celsius, and on Greenland at temperature 2 -53 degrees Celsius. Solution. According to the linear expansion, which is d equals initial diameter parenthesis plus 1 plus the constant times the change in temperature. First, for the Death Valley, which is 48 degrees Celsius. 1.9 parenthesis plus 1, 1 plus 2.6 times 10 raised to negative 5 Celsius times 28 degrees Celsius, which is 1.9014 centimeters. Second, for Greenland, which is negative 50 degrees Celsius, 1.9 centimeters parenthesis 1 plus 2.6 times 10 raised to negative 5 degrees Celsius times negative 73 degrees Celsius, which is 1.8964 centimeters. On a hot day, the length increases, and on a cold day, the length decreases.